I would like to thank the sponsor of this video, Statistics.com, who has been educating students and professionals in data science from all over the world for over 20 years. But more about that later. Let's get started. Hello and namaste. My name is Brandon, and welcome to this very first video in my new series on time series analysis. So we'll start at the very basics. Let's go ahead and get started. So first, welcome to the new series. If you are new to the channel overall, welcome to Time Series 101. For Statistics 101 viewers, welcome back. These videos will be very similar and familiar to you. We're going to start with the absolute basics and then work our way up. So if you've never worked with time series before, this is the place for you. Now over time, all aspects of time series analysis will be covered. Both the quantitative aspects, which we all think are cool, as well as the judgment-based techniques, more qualitative, which is actually how things really work in real life most of the time. Now, everything we do will be done in Excel and R. Now, if you're not an expert or familiar with R, don't worry about it. Neither am I. R for me is just a tool I use when I need it, so don't worry about needing extensive knowledge of R. Now, unless there is a very good reason to deviate from Excel or R, we're going to stick with just those two. So let's start with a friendly bet, a scenario. On Thursday, June 30th, 2022, the adjusted closing price for Microsoft stock was $256.83 per share. Now, without consulting any other information, you and your friend Ravi make a, quote, friendly bet on the next day's, which would be Friday, July 1st, 2022, Microsoft stock price. The person with the closest forecasted price to the actual price buys the other a beverage of their choice. So you and your friend Ravi are just sitting around. You want to make a friendly bet. Maybe you want to win a drink from your friend, and you just say, hey, let's have a friendly bet about the next day's Microsoft stock price. So therefore, this is a simple, educated guess about the Microsoft share price tomorrow using your common sense knowledge. Now note here that time series forecasting is bad. It's very bad for predicting short-term, one step ahead or one period ahead stock prices. Stock prices tend to move in what's called a random walk. Now I'm using this example just for learning purposes, but keep in mind that when trying to predict the stock price of something tomorrow, it is essentially random. So what do you already know in the situation? So note that what we're about to do is in the family of forecasting techniques based on judgment. It's a mix of experience, anecdotal evidence, common knowledge, and expert opinion. In the area of finance, you could think of someone like Jim Cramer or another guest on CNBC, or maybe something you read in the newspaper. So this is about judgment based on experience, evidence, common knowledge, and expert opinion. Now you know that the broader economic situation during this time period is negative and volatile. You know this because you are living through it. There are supply chain crunches all over the world. Inflation is an issue in many parts of the world. There are labor shortages. People are rethinking their relationship to work. And of course, there is a smoldering pandemic. So that is your lived experience, common knowledge that's going to help you determine what stock price you might forecast for the next day. That being said, Microsoft is a very established company, as you all know, with a stable, solid business model, and is perceived as well managed overall. Now, because of that, companies like Microsoft rarely have wild swings in their daily stock price. Almost all daily movements are within plus or minus 3%, and the vast majority of change is within plus or minus 1.5%. Unless the overall market swings drastically. So what we're saying here is that when you make your educated guess with your friend Ravi, the bet you're going to make, you're using some common sense knowledge here. You're using the world you live in, your experience, what you know about the state of the world. You are using the characteristics of Microsoft and similar companies as a company, that you know that their stock price doesn't swing wildly unless there's something underneath that's causing the entire market to swing. None of that is based off any research or any quantitative data. It's all based off what you know already going into this forecast from your own experience. So what else do you already know here? So the June 30th, to July 1st period crosses Q2 and Q3, so the second and third quarter for most firms, which could affect stock prices. Sometimes the final day of a quarter can cause fluctuations in stock prices as investors consolidate and manage gains and losses for the preceding quarter, so in this case, Q2. So again, as a business-minded person, these are things that you just already know when you go to inform your friendly bet forecast. Now, it's also the case in 2022 that Friday, July 1st leads into a holiday weekend in the United States, the 4th of July weekend. And of course, that might affect the stock price on Friday, July 1st. So again, as an economically minded person, these observations are just common knowledge for you. They're not research findings, nor are they based on a long series of prior closing prices. So you did not go to Yahoo Finance and look at the closing prices over the past 2 weeks or whatever to come up with your educated guess. This is fundamental to judgment-based forecasting. And I will say here that more quantitative forecasting and judgment-based forecasting are not exclusionary. There's overlap between the two, of course. But in general, these sorts of forecasts we're talking about here are just based on your common knowledge, not a long series of stock prices that you are doing some advanced quantitative analysis on. So let's formulate a guess. Given the 6/30/22 stock price of $256.83 per share, and knowing that almost all daily movements are within plus or minus 3%, and the vast majority are within plus or minus 1.5%, you and Ravi work through a potential price on Friday, July 1st, 2022. At $256.83 per share, a 1% movement is about $2.57 per share in dollar terms. So when you make your educated guess, you're kind of working, if you're thinking about 1% movement either way, you're going to add or subtract $2.57 per share based on the price above of $256.83. That will allow you to make an educated guess within the parameters of what you would expect. So you come out with a forecasted guess. We're going to forecast an increase in Microsoft share price up to $257.83 per share. So your forecast is for it to increase by $1 per share from $256.83 to $257.83. Now Ravi thinks it's going to decrease. It's going to go down. So Ravi forecasts a share price of $254.33 per share, which is down from $256.83. So you're going to forecast an increase, and Ravi's going to forecast a decrease.
This is Business Analytics using forecasting.
Hello, and welcome to Persuasion Analytics.
I will be your instructor in the next 4 weeks as you learn about interactive data visualization methods.
This course will be an exciting opportunity to learn about and play with modeling that's influencing our daily life.
Data and statistics touch every facet of our lives. In fact, that is why you are here on my channel. Statistics.com is committed to preparing the next generation of data analysts, just like you, while being human-centered. And, depending on your school, you might even be able to earn college credit. Classes are relatively small and personal. As a student, you aren't just a number. You can ask questions directly to your instructor, who, quite often, literally wrote the book, and receive a quality education with a personal touch. Statistics.com was the first online education institution approved by the American Council on Education. In the beginning, only one course was offered. Now, 75 courses are offered, covering the gamut of data science education. Many students are working adults from all over the world, and because courses are offered asynchronously, students can still maintain a career, family, and personal interests while also studying what they need to learn to take the next career step as a data science professional. For more information and a special discount offer from Statistics.com, please see the description below. Now, back to the video. So first, before we get into looking how the forecasts work out over time, we have to get some general notation sort of in our skill set. This is going to be very basic, and I just want to give you sort of what you're going to see as you learn about time series. So it's important to note that while this is the general notation, it can vary based on the source. So if you read textbook A, it might have notation like you're going to see here. Textbook B might be slightly different. Textbook C or an online resource or whatever else might look a little bit different, but the basic general notation is going to be the same. So they might be different in terms of capital letters versus lowercase letters, stuff like that. But basically, this is what you'll see. So of course, T is the time period. This is an index of equal time periods. It's important to point out that when we're looking at time series as we normally think of it and we do the analysis, all of the time periods are of equal spacing. So if we're looking at daily prices or daily energy usage or whatever else, the whole time series has to be daily. We can look at weekly, monthly, quarterly, yearly, whatever. If we're talking about sensor data, that could be every 30 seconds. It could be every minute. But the spacing between measurements is the same. So Y is the value at that time period or the data. So it's a series of n values, so some number of values over that same number of time periods. So for example, if we're looking at monthly data, we would have in a given year 12 values for each of the 12 months. You get how that works. So Y sub T, for instance, is the value at time period T. So if we're talking about today, Y sub T would be today. Now, Y sub T plus 1 would be the value at the next period. So that would be tomorrow. F is the forecasted value. So whatever time period we're looking at, so F sub T, for instance, is the forecast at time T again. And then F T plus 1 is the forecast at one step ahead. So it'd be the forecast, for example, for tomorrow. Finally, we have error, so E. You might see this written with epsilon or whatever else, but the general, just like in statistics, you'll see things written with sort of a regular quote letter, not a Greek letter. So E is the error. I'll call it E going forward. So forecast error at time T is E sub T. So it's the difference between the actual value and the forecast for that time. And again, this will all come into play here in a second when we actually look at the numbers, but the basic four parts are the same. So T is time period, Y is the value at that time period or the data, F is the forecast value, and E is the forecast error. So a few more things. The letter I just means equal steps forward or backward. So if you see something like this, which is a generalized formula, Y sub T plus I is just a stand-in for the number of steps you go forward if it's a plus. Of course, if it's in reverse or backwards in time, that would be minus I. So it could be T minus I. F T plus I is the forecast I steps forward. F sub T minus I is forecast I time steps backward. You kind of get how this works. Forecast error is the same. Forecast error is the same backwards. Now you might be thinking, Brandon, what do you mean by forecasting backwards? I thought we only forecasted forward. Well, in most cases that's true, but there is something called backcasting. We can and we will forecast backwards. So a brief example, let's say you're working with a data set where the data only starts on January of the year 2000. There's no data before that. It doesn't exist. It wasn't measured or anything. But let's say you want to get the data for the year 1999. Let's say it's monthly data and everything you have is monthly. So you could forecast backward into 1999 from the data you have from the year 2000 onward. We just run it in reverse. And you can come up with backcasts into the year 1999, even though you don't have any data to go with it. So we'll talk more about that as we go. But yes, backcasting is a thing. Easing into the notation. We have to have a starting point for our time series analysis. That's usually Y sub T. That's our reference time period. That's where everything goes forward from here and backward from here in time. And we write that as Y sub T. So on the day that you and Ravi make your friendly bet, we're going to use that as Y sub T today. The stock price was $256.83. Now you're forecasting into tomorrow. Well, that's T plus 1. So if today is T, tomorrow is 1 day forward because we're doing daily forecasts, T plus 1. That's the value at a future time period, tomorrow. And likewise, T minus 1 would have been the stock price yesterday. So on the 30th of June. So you can see how this works. Most important thing to get out of this slide is that we're always starting from a determined reference point. In this case, we're calling that today, but it could be this week or this month. It doesn't always have to be now necessarily. So if we're looking at something that occurred at a different point in time, and we're looking at the forecasts forward or backward from that time, Could have been a year ago or 5 years ago or whatever else. That would be a different time period. So it's all about where you choose to start. That's going to be Y sub t. In this case, with our friendly bet stock price, it's easy. It's just today. Tomorrow is t plus 1. Yesterday is t minus 1. Next, let's evaluate your educated guesses, your friendly bet. On Friday, July 1st, 2022, Microsoft closed at $259.58, which is the actual price you were forecasting into. So who won the forecast price friendly bet? Closest in either direction. If, positive or negative, doesn't matter. Whoever was closest. So your forecast, your guess, was $257.83. Ravi's was $254.33 per share. So the actual stock price on that Friday was $259.58. So your forecast was $257.83. Obviously, those are different, but we've got to figure out how close you were. To evaluate Ravi's guess, of course, we have the actual price of $259.58. His forecast was $254.33. So who was closer? So your forecast was $1.75 off. It was actually $1.75 below the actual price of $259.58. Now, of course, when we say error here, it's not a normative judgment. Error doesn't mean you are bad or not smart or anything like that. When we're forecasting, we're always going to have error. That's the idea of forecasting. So your error was $1.75 under. Ravi had a forecast error of $5.25. So you can see the difference between the actual price there in the green and then your forecast in blue, Ravi's forecast in orange, and then the difference between the two. So you won. Congratulations. Of course you won because you're watching this video. I'm not going to have Ravi win. You're watching. So measuring the forecast error. So the forecast error equals the actual value minus the forecast value. We can write that as E t plus 1 equals y sub t plus 1 minus f t plus 1. It's just error equals actual minus forecast. So here's the actual and the forecast from you. The error is the difference between the two. So 259.58 minus 257.83. That's an error, like we said, of $1.75. For Ravi, the difference was 259.58 minus 254.33. The error there, $5.25. So simple subtraction to find the forecast error. But remember, the actual comes first, minus the forecast value. Now note that both errors are positive. This indicates a forecast that was too low. The actual price surpassed both forecasts in this case. Think of it as what we would need to add to your forecast, each of you, to get to the actual value. To get from your forecast of $257.83, we would have to add $1.75 to get to the actual price of $259.58. Same thing in Ravi's case, just different numbers. A positive error means the forecast was too low because the actual is larger. So here's a visual look at how this works. Here was the actual price on the 30th, so $256.83. You made a forecast of $257.83. Therefore, that is your forecast of time plus 1. Ravi had a forecast of $254.33. That's his forecast at time plus 1. The actual price, after the next day happened, was $259.58. So the price, the stock price there, had a gain of $2.75. It went from $256.83 up to $259.58. Now your error is the difference between your forecast and the actual price. You can see there with that arrow in the blue. Ravi's forecast error is the difference between his forecast, there in the orange, and the actual price at the top. So you can see how the forecast errors are related to the beginning and the end. So the price at time t and the actual at t plus 1, and then how your forecasts fit in between those two. So lastly, percentage error. This is very simple. So a percentage error is just the error over the actual value, the actual price. So it's just E t plus 1 divided by Y t plus 1. Very straightforward. So in this case, your error was $1.75. If we divide that by the actual price when it happened of 259.58, your percentage error is 0.67%. For Ravi, do the same math. The forecast percentage error is his 525 error divided by the actual price, and that is an error of 2.02%. So we're changing here the actual dollar values into a percentage to get a standardized value by percentage change. Now also notice, because the errors are positive, the percentage error are positive. There will be things that we learn later where we take the absolute value of error terms and then the sign won't matter. But in this case, because you and Ravi under-forecasted, the errors are positive, which leads to a positive percentage error. But of course, if either of you had guessed over 259.58, the error term would be negative, and therefore the percentage error would be negative also. All right, let's wrap this up. Conclusion and review. So time series forecasting can be divided into two basic camps that sometimes overlap: judgmental forecasting and quantitative forecasting. In everyday practical use, and I can tell you this from experience in my day job and other jobs I've had and just my life in general, judgmental forecasting is very common for many reasons, which we will discuss. But a lot of everyday business, a lot of everyday just our lives run on judgmental forecasting based off our common knowledge or prior knowledge or experience and what have you. For time series and time series forecasting, the basic measures are the value now or in the past, the forecast value, and the forecast error. Those are the three fundamental things we look at. There are many, many ways to develop forecasts. It's fundamental to quantitative forecasting and judgmental forecasting for that matter, and will make up a large part of these videos. But the basic process for measuring forecast accuracy is the same. It doesn't matter whether you just pick a number out of a hat, whether you use something like a moving average, or you use something complex like a recurrent neural network. Doesn't matter. In the end, it's going to spit out a forecast value. Then we'll measure that against the actual value, and then there will be almost certainly some sort of error. So a lot of this is all the many ways that we can develop forecasts and all the many ways we can evaluate the errors. That's fundamental to quantitative time series forecasting. So as I said, there are also many ways to evaluate forecast accuracy, and that will be a huge part of all these videos. So generating forecasts is one side of the equation, and evaluating those forecasts for their accuracy is sort of the other half of the equation. So generating forecasts and measuring their accuracy is a means for better decision making. We're doing this for better decision making, whether that is where we're going to invest money, how we're going to budget for energy use, how we're going to figure out resource allocation potentially, how we are going to make governmental or business policy. It's all for better decision making. So even though we can't know the future, otherwise why would we do time series forecasting in the first place? What it can let us do is not have to make decisions in the dark and not have to make decisions or important allocations that are just essentially random guesses. That's what time series can allow us to do. So of course, that is what we will continue to do in these videos going forward. Okay, that wraps up this first video, the very basics of Time Series 101. I know there was quite a bit in there, but what I wanted to do here is sort of give you an overview of the basics through sort of a friendly common example with guessing a stock price there, and kind of get you used to what you're going to see as you look at textbooks that talk about time series or other resources, as you go out and maybe analyze your own data. Maybe when you open up a software program, you're going to see something in there. So the idea here was to give you a brief overview, a brief survey of some of the basics. And of course, as we go, we will go into more depth on these topics. So thank you very, very much for stopping by the channel and for watching. And I look forward to seeing you again next time. Take care and bye-bye.